and produce the alanine. Alanine secreted into the blood and transported to the liver. Here you can see forms the glucose alanine. So through this kind of method, you can see the alanine transported into the blood, transported to the liver. In the liver, you can see deamination and produce the pyruvate through the gluconeogenesis, produce the glucose. Glucose secreted into the blood, back to the muscle, like this. So this kind of the transportation methods have the important function. You can see significance of the alanine transportation, the ammonia. The amino group of the amino acid in the muscle is transported to the liver in the low toxic alanine, and the liver use the alanine produce the glucose and transport it to the muscle. So it's very important. In the liver, you can see ammonia used to synthesize the urine. In the liver, this is the main route. Maybe some students think this kind of the basis and produce the urine. Urine, no usually, but my students pay attention to. Compare the ammonia and the urine. Urine, no usage, but here urine, the low toxicity. It is safety molecule. So the metabolic pathway for the ammonia in the body, in our body, you can see many in liver synthesize the urine. It is the main metabolic pathway. And the second, synthesize no essential amino acid. Last time, so we studied the amino acid three source come from three parts. And another one you can see can be synthesized the glutamine. Glutamine also it is another kind of the amino acid. And another one you can see excretions ammonia from the kidney tubules directly, and ammonia have the toxicity, and the times in the kidney you can see directly transported and secreted excretion ammonia from the kidney. So here, pay attention to under acid condition, the ammonia converted to the ammonia ions excreted with the urine. Maybe forms the salt, and so on, can be directly excretion the ammonia. So this is summarize the metabolic pathway for the ammonia in the body. So and we began to study another way. The first here you can see the main metabolic pathway synthesize urine. Synthesize urine. So we study this is the Kruppus and Henslater cycle. Also names the urine cycle. and another name, it is the Ornithising cycle. Why? Here you can see first, this cycle, you can see every cycle and synthesize one molecular urea. And this cycle and discovered by the Krupus and Henslater. Henslater is the students, the Krupus students. So Krupus, the teacher, Henslater students is very, very famous in biochemistry. Uh, this cycle, you can see, synthesize every cycle, synthesize one molecular urea. So give the names also those as the urea cycle. And this cycle discovered by the Krupus and Henslater. So also names the Krupus and Henslater cycle. This cycle, every time you can see, produces the ornithine molecular. So we also give names is the ornithine cycle. This in the liver finished the cycle. Uh, in the liver cells, mitochondria and the cytosol. Here you can see. Uh, in the mitochondria, you can see produced the you can see here produced the glutamate. Glutamate also can be deamylation, dehydrogenase, catalyze, produce the free ammonia. Another one you can see glutamine. All kinds of the molecular you can see transported, you can see in the from the brain or brains and the muscle transported with the glutamine. Another ones you can see transported with the alanine, and sometimes you can see transported to the liver. In the liver cells, you can see in the mitochondria, transported into the mitochondria, and you can see glutamine. You can see glutaminase catalyze produce the glutamate and the free ammonia. And another one you can see in the liver, in the cytosol, you can see through the transaminase catalyze. You can see the alanine from the muscle. You can see here the ammonia group transported to the alpha ketones glutamate carrot and produce the glutamate transported into the mitochondria. So, and then also you can see this PPT explained for all of you. In the liver, how to produce the free ammonia. In the liver cells, this molecule you can see quickly and begin to convert to synthesize the urea. How to produce the urea? You can see here reaction. The first chemical reaction you can see. They use the carbon dioxins, ammonias, waters, ATP at that times catalyzed by the combinamyls phosphate synthesis 1 and produce the combinamyls phosphate. Combinamyls phosphate. This molecule you can see contains the higher energy bond. Higher energy bond. You can see this chemical reaction, pay attention to for my students. This This chemical reaction is very special. You can see here, these enzymes need the N-acetyl glutamic acid. This molecule you can say act as activator, and sometimes can be catalyze the chemical reaction. You can see here. And the second chemical reaction, oh here you can see, need this molecule act as the activator. You can say act as the activators to Camimil's phosphate synthesis 1. You can see here the chemical reaction. The first Camimil phosphate synthesis 1 catalyzed produced the Camimil's phosphate. And second chemical reaction you can see here. The one molecules adenosine and one molecules Camimil's phosphate and adenosine aminotransferase catalyze. You can see produce the citrulline. Produce the citrulline. You can see the first chemical reaction and the second chemical reaction finished in the mitochondria and produced the citrulline and quickly transported out of the mitochondria. Transported out of the mitochondria. You can see, and next chemical reaction, you can see citrulline transported out into the cytosol, and added one molecule aspartate, and adeninosulfate synthesis catalyze and produce the adeninosulfate. You can see here in the cytosol, the first chemical reaction, the adeninosulfate synthesis catalyze. And another one, the adeninosulfate lysis, adeninosulfate lysis catalyze and produce the adenine and the fumaric acid. The second chemical reaction finished in the cytosol. And another one, you can see the adenine catalyzed by the adenines and produce the urea and the adenosine. Adenosine quickly transported back into the mitochondria and take part in another molecules urea take place produced. Here you can see for all of this you can see the first and the second chemical reaction finished in the mitochondria. You can see citrulline transported out and bonded with the one molecules sulfate aspartate and produces the adeninosulfate. In this molecule, you can see the lysis catalyze produces the one molecule of fumarate and produces the one molecule of adenine. Adenine, for all of the you, is very familiar. It is the basic amino acid. You can see the adenine catalyzed and catalyzed by the adenines directly cleavage and produce the one molecule urease, one molecule adenosine. Adenosine quickly you can see from this line you can see back to the mitochondria. So totally 3 part, all kinds of the molecule you can see transported the amino group to the liver. In the liver you can see and with the glutamines, alanine, glutamine directly transported into the mitochondria. Alanine in the liver's cytosol through the transaminase and produce the glutamate. Glutamate transported into the mitochondria. In In the mitochondria, you can see the glutamate, you can see dehydrogenase, catalyze. You can see produce the free ammonia. Ammonia, carbon dioxide, ADP, catalyzed by the comprimers phosphate synthesis 1 and produce the comprimers phosphate. This molecule you can see catalyzed by the adenosine amino transferase catalyzed, and you can see produce the citrulline. Citrulline produced quickly transported out of the mitochondria in the cytosol and bonded with one molecule aspartate and produced the adeninosuccinate. Adeninosuccinate, you can see catalyze adeninosuccinate lysis, catalyze and produced the adenine. Adenine catalyzed by the adenines produce the urea. And again, produce the one molecule produce the adenosine. That times adenosine transpacted into the mitochondria. Okay, this is a very important cycle. It's a very important cycle. We studied the group cycle, the tri-carboxylic acid cycle discovered by the groups. And here you can see groups discovered the second important cycle. Okay, for this part, my students reviewed this cycle and reached 10 minutes.
OK，老师。
你来听我怎么样？你那个你念完系统，你抓来有心走，系统。这个夏老师说我这分我跟他说我先养养的，现在基本没有是吧？那你分了之后，你分了这个状态，我 这是一个节，第二个节不是不是你就是中间它好像就是在起个一个我激动啊！现在这个你把它炒，啊，这个炒，都是都你看这个多少？不点细胞，哦，一定细胞分，它这个是细胞，好几个都不变了，没错，不见到我的手，现在一样。这样，我这种统计，让大家这两天我说，中有空了时间，这个就是搞这个中 你要讲过写点文章的什么项目的什么？有想法的要2个人发。
Okay, continue. Mm. This BBD, uh, in fact, summarize above 20 PPT from the examinations and choose the produce the free amino ammonias molecules and 5 step of the carbohydrate cycle. For this, you can see here the synthesized carbamylose phosphate required 2 activation steps. Consumes 2 molecules ATP. You can see, and you can see bicarboxylate, and you can see produced the carboxylic phosphoric acid, anhydrate, and furthermore, you can see bonded with the ammonia, produce the carbamate. Carbamate, you can see furthermore produce the carbamylose phosphate. Here you can see carbamylose phosphate synthesis 1. Next unit about the metabolism of the nucleic acid. We studied at the times you can see also produced the carbamylose phosphate and the substrate different and the enzymes different, and we studied at the times you can see use the glutamines and produce the carbamylose phosphate. And at that times this names is the carbamylose phosphate synthesis 2. And next unit we can compare this to kind of the enzyme. Okay, you can see for the urea cycle summarize, you can see 2 molecules of ammonia. 1 molecule come from the ammonia. You can see ammonia produce the carbamylose phosphate, and another come from the aspartate. 2 steps finished in the mitochondria, 3 steps finished in the cytosol, and 3 molecular ATP take part in the chemical reaction. In fact, need 4 molecules ATP. For example, here this chemical reaction you can see, 1 citrulline, 1 molecule citrulline, and 1 molecule aspartate. You can see the adeninosynthenase synthesis. Kind of nice. You can see here ATP lysis the released energy produced the AMP and PPI. PPI, we studied the fatty acid. I explained for you. This quickly lysis. So use 2 molecules ATP energy. So totally 4 molecular ATP. For this, you can see urea cycle regulated by the dietary protein and the 2 rate limited enzyme. Steadily, the ammonia also can be come from the nucleic acid, but most ammonia come from the protein. So if you eat too much protein, and that times produced the ammonia come from the protein is not, and that times maybe promote the urea cycle. And another one you can see the IgA activity, the activity of the carbamylose phosphate synthesis 1 and to synthesize the urea. And another one improve the activity of the adenine synthesis. Also promote the synthesis. You can see here. Adenine synthesate. Adenine succinate synthesis also promote the here you can see. These two related enzyme. You can see the activity is very low. So related these two enzymes can be regulated the urine cycle. And last, you can see disorders urine synthesis can cause the higher blood ammonia and ammonium points. And at times you can see synthesize the urine may be obstacle, and at times you can see can be forms the hyper ammoniemia. Common defect in the synthesized urine cycle related to the enzyme. You can see just we studied the 5 steps. You can see the 5 enzymes. Okay, and another one you can see the higher blood ammonia disease caused the brain dysfunction, said the ammonium poisonous. What happened? And possible mechanisms things you can see, and at times you can see alpha ketone glutamate can be used to synthesize the glutamate and produce the glutamine. And at times maybe the alpha ketone glutamate may be shorted. At that times alpha ketone acid in the brain decrease and decrease the Krebs cycle, and produced energy may be shorted, and that times makes the brain dysfunction. So today we studied the metabolism of the ammonia. Study here is okay. For this unit, have the another things, and I send to you the PPT. Today you read the chapter 27 and continue to hope all of the students studied this chapter 28 by yourself. Okay, tomorrow we begin to study the next unit about the metabolisms of the nucleotide. Okay, today we stop here.
OK，老师，
OK，老师，
谢谢老师，再见。